Good day, everyone, and welcome to SolidWorks Live. So today's episode is called Challenging the Manufacturing Status Quo. And you might be thinking, SolidWorks is a software company. Like, you guys make 3D design software. And while that's true, here are a couple additional truths to add to that list. There may be no domain, not simulation, design, or any other where a team here at Dassault Systèmes has made such an effort to go above and beyond software as our manufacturing group has. Another thing to add to the list, we have been lucky enough to foster amazing connections over the years across the manufacturing industry. And these connections have massive audiences and causes of their own, like Mavens of Manufacturing, YouTuber Jeremy Fielding, and industry powerhouse Titans of CNC. And lastly, manufacturing and design are, after all, inescapably intertwined, right? And while this is something our community members know and can attest full well, I believe this is something that's beautifully evident at the software level as well. So during this episode, we'll talk software, of course. How are we innovating and how are we changing and going beyond the status quo with technology? But we'll also talk culture. Where are we seeing strides in diversity and inclusion inside of manufacturing, and how can we all help? And we'll also talk with real industry customers about design to manufacturing workflows. And if you're still not convinced this is going to be an awesome episode, YouTuber Jeremy Fielding is also going to take you on a personalized virtual tour of the National Institute of Aviation Research in Wichita, Kansas, to show us how they're using some of the latest enhancements in one of the coolest sectors out there. Let's start at the root. If you only know SOLIDWORKS as an awesome design software, there is so much more to that story. And earlier this week, I got the chance to chat with Chris Meaghan. Chris is the technical expert in charge of our manufacturing content. He's held roles as a machinist, an additive manufacturing leader, and much, much more. And so I thought there would be no better person than Chris to make sense of how SOLIDWORKS customers are challenging the status quo with the latest solutions in manufacturing. An idea that, as I discussed with Chris, isn't exactly new to us or our community. So let's take a look. All right, joining us here is Chris Meaghan. Chris, welcome to SOLIDWORKS Live.
Well, thank you so much, Sean. It's great being here.
Absolutely, man. So for as long as everyone watching today has known about SolidWorks, right? They've known we've been pushing the envelope on design for what, almost 3 decades now.
Yeah.
And they might even know that we've added portfolios or tools to the portfolio to make it easier to do things like machine and inspect those designs as well. And, this episode is about challenging the status quo in manufacturing. And I wanted to ask you, Chris, what are some advances at more of a technological level that we've been helping our customers with today within manufacturing that are really moving the needle again in terms of what's possible?
Yeah, Sean. So let me just say that, first of all, thanks for having me. But it's questions like this that make me really, really excited to do episodes like this and to talk about Dassault and where we've been and where we're going. It's just really exciting. When we look back at the evolution of SolidWorks, as a company, we were addressing that bottleneck that happened in engineering, right? Drawing like old 2D drawings and stuff, and it just took forever and all this other stuff, but we made it 3D. Not only did Dassault and SolidWorks make it 3D, but they made it 3D and easy. So the power and the ease of use alleviated that bottleneck. So congratulations, everyone. That bottleneck in engineering's over. Your job's easy now. That's right, we did it. So, but moving forward, it's like, okay, we've got the engineering department and we know their wants and needs and we're addressing them and we're taking care of that. Dassault as a whole is looking more at the entire company, right? Where else can we alleviate these bottlenecks to make these companies more successful? And I think something that a lot of us forget sometimes is that when we're designing in any design software, be it SolidWorks or XDesign or anything like that, the end result is a physical part, right? So to alleviate any kind of backup or anything like that in the manufacturing department is going to make that company run a lot better. And Dassault knows this, and they know that that's really kind of the next progression with software, right? Now we got the design and engineering down. Now let's make sure that we can get those parts out the door as fast as we can.
Awesome. Yeah, let's talk about that, right? Like, and I loved how you put that. So much of so many of us we're so focused on 3D designing things, and right, if you ever kind of go, and that's something we talk about with one of our other guests, Eric Timmons, who focuses on design to manufacturing workflows. Right, if you just focus on the 3D model, you're really just making pictures. Like it's
Yeah,
kind of where you are. And of course, no one really makes, well, I guess some people do, but
yeah.
a lot of us wouldn't make any money at all if we were
Mhm.
just focused and we stopped at the 3D CAD model, the 3D picture. And one piece of technology that we're developing that really has me feeling inspired lately is something called Factory Simulation Engineer, right? And this is a tool that many of our customers are using today, right? So I wanted to ask you, as one of our manufacturing experts here, how are some customers leveraging a tool like Factory Simulation Engineer today in a way that has, like kind of like you were saying, materially changed how they're making their parts and how they're running their factories?
It's incredible, and there's a lot. So my background is machine. I was a machinist for way longer than I'd want to admit. But when I was actually in the shop, I mean, there was aspects of it as a machinist, as an employee, right, that I never really considered. And one of which was, how are these parts flowing through our facility, right? I mean, my I was really focused on my one mill and my one lathe, and I had the cell that I was responsible for, and it was great, but I never really looked at the overall shop or the overall manufacturing facility like a manufacturing manager or factory manager supervisor might. Now, when they do this, how do they make sure that the conveyor belts are running at the right speed or the machines are in the
Mm.
right place? I mean, how many times have we worked somewhere where it's like, oh my gosh, I got to walk all the way around to get this part and then walk all the way around back? So with factory simulation engineer, we're able to take a lot of lean manufacturing practices, a lot of data driven analysis, and help our customers rearrange their shop to make sure that it's flowing the best way possible. Now, that's just the initial. Now, if you already have a shop, let's take MetalQuest, for instance. We've done a lot of case studies with MetalQuest. They're in Nebraska, absolutely amazing production facility, and they're a job shop, so they have to be very agile, they have to be very precise with their machining, where their machines are, how long it takes. They use factory simulation engineer to make sure when they move the machines around or even buy a new machine, if the flow of that factory is going to make sense. Do they put it in the front? Do they put it
Interesting.
in the back? Is it worth it to move four machines to put that one machine where it is? It's things like that. And you can run real time analysis, not only with moving machines, but you can also do time analysis with human beings. How long does a person take to walk from here to there to load a machine? You can do unmanned vehicles or auto vehicles, the little things you see in the Amazon commercials going around. It's a really powerful tool that with paired with our robotics engineer role, it's just incredible. I mean, taking these robots, taking the time analysis from these robots and looking at it in a holistic workflow with simulation engineer is amazing.
And with Factory Simulation Engineer, I think, and some of this I'm sure our audience can see through some of the clips that we've been showing here. One of the things I find amazing is how we even get that factory data into the system to be able to begin doing this sort of logistics planning, as you've been mentioning. So what is it? Is it scan data, or are we bringing in
Right.
CAD data models from the machines themselves, or the robots themselves? Like how is that happening?
That's great. And really the idea of where Dassault is going now is not just giving you the power to do these things, but really giving you the ability to do it, right? There's a difference, right? We can give you all the power in the world, but if it's too confusing or too much, right? You just won't use it and it's not efficient. Now, with factory simulation engineer, this is a really great example of kind of simplifying and making the product something where everybody can use, right?
Mhm.
You can use 2D data, you can use AutoCAD data, DXF files, and just kind of lay out your factory. You can do simple time studies using just 2D. no problem, right? You can do that. But you could also use your existing 3D models of machines or tables, robots, whatever that might be, and then move them around your facility virtually. Sorry, move them
Mm.
around virtually to see where they're going to go. So if you don't have those existing 3D models of things
Mhm.
in your facility, we actually offer scanning option where someone
Wow.
actually, this is actually super cool. Somebody walks around your facility with a little backpack and a scanner, and it actually takes up data points, and it gives an incredibly accurate scan of your facility. Once that's done, that scan data is broken down into actual usable units. So let's say you scan a CNC machine. You can actually take that scan of the CNC machine and move it around virtually to see where that's going to go. It saves a ton of time for modeling.
So, Chris, one area I wanted to ask you about, in addition to all this great technology that we've been speaking about today, is more on the cultural side. And I think that you guys over on the manufacturing team, you've done such a great job of leading not only with the technology but also with the people stuff and getting people's stories out there and talking about what's really going on out there in the manufacturing industry. And I can think of no area where that is happening more evidently than with our manufacturing live show that you are always participating on, and is run by our own Mike Buckley here. So, as we exit this session, can you give our audience here today a little bit of a primer on what Manufacturing Live is all about, and also maybe some examples of some guests that we've had on through to today?
Absolutely. So one thing about where Dassault and 3D Systems is really going with manufacturing is looking at, as you can tell from this interview, it's a more holistic view, right? One thing that when you hear SolidWorks and manufacturing, you just think CAM, right? I'm gonna program my CNC machine. What's the G code look like? How do I make pockets? And it's fine, right? That's a very big part of it, but it's only a part. And that's where Manufacturing Live comes in. We start addressing the issues that real facilities have, right? These aren't theoretics, right? Um, our episodes are great on the SolidWorks YouTube channel. We're releasing on a regular cadence. We have guests like Titans of CNC, some of the employees there talking about the challenges they have, not only programming their CNCs, but design and governance, communicating. There's really several other manufacturing engineers and business leaders. I mentioned MetalQuest. They were on Behlen Manufacturing. There's been some engineers from there on. And we're doing a really, really great project with a company called Bowhead. They actually make adaptive bicycles, and they're up in Canada. We're
Yeah.
really looking forward to working closely with them in Manufacturing Live too. So, what the message I would want to tell everybody about Manufacturing Live is, it's not just about cutting parts, right? It's about the entire manufacturing process, and we love to have interaction with our prospects and customers. So please tune in.
Awesome. Well, everyone, make sure to subscribe to the SolidWorks channel. You'll get alerts whenever we have new episodes of not only SolidWorks Live like today, but also Manufacturing Live. Chris, thank you so much for jumping on, man.
Thank you, Sean.
So, hey, it was great to chat with Chris to get a lay of the land on how those of us in industry are working with robotics and optimizing our logistics and factory flow processes. But I might be able to think of something that is potentially even more fun than talking about that. So Jeremy Fielding, you might know him as a YouTuber with nearly 1 million subscribers who is hyper dedicated to educating the world on engineering, fabrication, robotics, and really all things kinematics. I am lucky to call him a friend, and we are all lucky today because we are about to go on a tour of one of the coolest research facilities out there at NIAR. So without further ado, let's see where Jeremy takes us as he teaches us the ways that he saw NIAR challenging the status quo while on site there just a week ago.
Hello, I'm Jeremy here live on campus at the 3D Experience Center, which is inside of the WSU college campus in Wichita. I'm actually here to visit NIAR, which is a research facility right here inside of this same building and actually spread all over the campus. The research that they're doing in manufacturing and engineering is simply incredible. They're doing cutting edge things with composites, with 3D printing, 5-axis CNC machining, and the way they've integrated the education into the research is simply phenomenal. So today I want to tell you a bit about what I've learned over the last couple of days of touring around with some SOLIDWORKS and Dassault Systems experts along with me in tow. One of the first sites that we went to was a location where they have essentially taken over an entire stadium, and they are reusing this facility in order to disassemble large aircraft. We're talking about airplanes, helicopters, and so forth that were built back in the 80s, maybe even slightly older than that. And these planes are still serviceable, they can still fly, but there are no CAD models. This was all hand drawn. So if you can imagine the curvy shapes and the surfaces that we want to still manufacture today based on handwritten drawings in some cases, created back in the 80s, it's quite the challenge to update this material for manufacturing. But that's exactly what they're doing. They are taking these planes apart piece by piece, scanning all of the pieces to get that 3D rendering. But they're not relying on the 3D render because there's several issues there, right? These planes, many of them have been repaired many times. Some of them have double plates. Some of them have things that were added during the manufacturing process to alleviate some problem. So how do we get around that? Well, in many cases, they have more than one plane, and so they can compare and contrast the two, which is fascinating by itself. But they scan all these parts, and at the end of the day, they compare all that to the original drawings. So I walked through a room with a team of CAD jockeys, if you will, all meticulously going through these old drawings. And that was really interesting in itself to see them taking those drawings, but they also have the 3D scan inside the model so that they can have a quick sanity check. I can make sure, yes, I have that curve going in the right direction and it looks similar, at least it looks similar to what we scanned. But by doing this, by going through this process of digitizing their parts and taking them from paper drawings to 3D, they're vastly improving the manufacturing process because modern manufacturing processes rely on CAD now. We're taking it straight from the 3D model, and some places are manufacturing without creating a single drawing. And if you can have the capacity to send a 3D model to get your parts manufactured, that's so much better than handing someone a drawing and then they're just gonna have to recreate it in-house every time one of your parts break, and then they're gonna charge you for that. So what they found is that if we digitize all these parts, not only do we have the 3D model that allows us to look up part numbers, look up the service history of parts, we can now document parts a lot better in relation to the 3D model. If you bring in a plane, and let's just say it's got a big bullet hole in it, something that tore off a large piece of the plane, well, what pieces were behind that? If you can go to the 3D model, you can click on that area and see everything that was supposed to be there, part numbers and everything associated with it. You've got that data in just a couple of seconds. Before, they would have to go through pages and pages, sometimes books full of pages, in order to find those parts, figure out what the part numbers are. That page refers you to another page, which is another book of drawings, and it's just so tedious and painful. We have advanced past that. So they're now digitizing these old planes to increase the service life. And that to me is just amazing. I was not able to record any footage there because obviously some of these planes, this information is still protected. But that to me is fascinating, that to see some of these drawings with all of these curvy surfaces, recreating that both with the 3D scans for your sanity check and confirmation of shape, and then also taking the what we're going to call the gospel truth, the written record, the drawings themselves. We still use those to confirm what the original engineer expected. Leaving that facility, we went over to another facility where they are doing all sorts of training for the next generation of welders, machinists, people who are doing CAD drawings, even those who are doing engineering and want to get some experience in front of the machine, which is something that they encourage here at this campus. even the engineering students are encouraged to take some classes over in machining and maybe even welding so that they have some experience with those processes. And I wholeheartedly agree with that. But walking through this building, I was amazed to find an entire lab that was just virtual reality welding machines. Now, you might be snickering like I was when I first heard that, because I thought that was just hilarious. Like, come on, man. You need to feel the heat on your face. You need to actually put some metal down. You need to see the parts, how they curl up when you put too much heat in a different position. How could you possibly learn to weld with a virtual welding machine? But the guy who was giving us a tour, he said basically the same thing. He said he was skeptical, but it was amazed at how well these students performed when you put a real welding gun in their hand. They did very well. And the equipment looks just like the real thing. You walk into the room, there's the huge box for the industrial welding machines. You've got a welding gun. You put on your virtual reality glasses. I didn't get to try this part myself, but as I understand, there's a test plate there, and when you do the motion, it responds accordingly as if you're welding, giving you the kind of result that you would get based on how you move, how you hold the gun, and so on. So again, another one of the many things that I found very fascinating visiting this place. Just a little bit further down the hall, they've also got several rooms dedicated to all different things related to composites. So in one room, they're taking composites and they're building up the layers. They've got the ovens in the back to cure the resin. In this same room, there's all kinds of mills. They've got lathes in the back, and they've got a couple of manual machines. But the room is definitely dominated by CNC, which is also a reflection of the current state of manufacturing. More and more people are moving to CNC, and we're seeing fewer and fewer of the manual machines. I know that's disappointing for some of you, but it's just the reality of what's going on. These machines are faster, more consistent, and they can crank out parts over and over. So that's the direction that we need to head, and that's what you want to teach these students how to use. But that doesn't mean we abandon those manual machines. They still have their application, and they were also located in this same room as well. So kids are getting exposure to that first, and then they come over to this other room, or in the same room rather, they can also learn the CNC machining. So these skills are being, the students that come through this program, as I mentioned earlier, some of them can be engineering students, but most of them are there just to be certified to do CNC machining or to do welding or even to lay up composites, which was another room that was located in this place. And they're doing all sorts of things with composites. Some rooms marked secret. You couldn't go inside and see what they were doing because this is also a research facility, right? And there are many things that are so cutting edge that you don't want to quite let everybody know what it is you figured out yet. So that was also fascinating. But we learned about composites. There was a significant amount of carbon fiber being laid up, being cured. And then one more room down, they're testing and breaking these pieces. And so they're punching holes in them, pulling them at the end, twisting them to see how they behave, and calculating those forces that this material can withstand. Such an amazing experience. This facility didn't just have the manufacturing side, there's also maintenance and repair that we can find in this same facility, training on things like tearing down motors. There's one room simply dedicated to aircraft engines where students were completely disassembling these motors, identifying the parts, repairing parts, lubing things up, doing maintenance things, doing repair things, and then putting all these components back together. They'd be graded on their performance, and it was that amongst many things, right? There was another area, an aircraft hangar area, just full of aircraft, and inside of this space, planes were at all different levels of assembly. Everything from some with the engines taken out, some with wings taken off, some that were nearly fully assembled, and even one plane that was fully flyable that they used for test flights. One of the things that impressed me most about walking through this facility is walking past a room dedicated to research, and some of them secret and some of them not. And then the very next room will be something about training the next generation, these students who are getting ready to be released into the marketplace. And by that, I mean the manufacturing marketplace. the guys that some of you will be hiring to do the machining work, to do the welding work. And you go down one more room and you've got people coming in for maintenance training, people who are not only the next generation of maintenance, but people getting recertified. And then again, another research room. And so on, you see this nice marriage between the various industries, where things are right now, what's coming next, and then also the students are right there in between. They're able to see what's happening now and probably what they'll be working on before they retire from their careers. To me, it was almost like watching this really fascinating timeline of these next generation students seeing what's happening now and seeing what's coming and being able to walk out with both of those pictures in their mind. They know what they need to do now, and they're already thinking about what's coming next. And those are the kind of people you want to hire. Frankly, I haven't seen anything like this where one facility has married all of these components together. Seeing these students come in, they're trained on what's happening now, but they also leave with this nice image of what's to come. You know, the very cutting edge, the things that are almost ready for manufacturing. They really did a fantastic job of bringing those things together and preparing these students for the manufacturing world. I could go on and on about all the amazing things that's happening here when we've barely talked about what's going on with all the research and development in 3D printing technology. There's quite a lot of things coming out, and I'm excited about seeing these technologies improve both in cost and availability so that we can see more of that in the manufacturing world. So I'm going to take this opportunity to throw it back over to Sean at SOLIDWORKS Live, and I hope you've enjoyed this little snippet here.
So Meaghan has become a leading voice for diversity, inclusion, and women in STEM everywhere. And during our short time together recently, we got to talk about what she is seeing out there. You know, what are the trends? You know, where are we seeing growth? How do we approach difficult conversations on changing the status quo? And perhaps most important of all, you know, why should we all care? So let's take a look at my conversation with Meaghan. Meaghan, how are you today? Welcome to the show.
I'm great. Thanks, Sean. How are you doing?
I'm doing awesome. It's always great to chat with you.
I think the last time we saw each other was at 3D Experience World. So
I know. That was 4 months ago. That was four months ago now.
Feels like it was yesterday.
Yeah, it's interesting. We just started, for those of you watching at home or at the office or in the shop, wherever, we just started planning on 3D Experience World 2024. So yeah, it's crazy. You know, you go right from that event and then right into planning. So we have some really awesome stuff that we're getting ready to show you guys in Dallas.
That's pretty awesome.
Yeah, and Meaghan, you're traveling a lot, right? So, you know, first question I had for you is, you know, over at Mavens of Manufacturing, you've spoken, for those of you at home who don't know, you've spoken with hundreds of manufacturing professionals in interviews over the past few years. You know, what would you say are the top 3 diversity points that seem to keep on coming out?
Yeah, so the number one that comes up for me, obviously, is gender diversity. So over the years, manufacturing has been predominantly male. So a lot of companies and organizations are trying to figure out ways to support more women and actually bring awareness to women about the opportunities that they can pursue at different career levels and different career pathways. And it's really refreshing to see that. So I'm really excited about that. But then you also have like your ethnic and cultural diversity, and that's really going to depend on what region you're in. So gender diversity seems to be a thing all over the world. Like I've talked to women in the UK, and they were saying that they were kind of struggling with the same thing, where like they just can't get women interested in some of the engineering positions that are available. So not just manufacturing, but there are other countries where women are more prevalent, like at the shop floor level, but you don't see a lot of women in leadership levels. And then I just got done having a conversation with someone where they brought up Thailand, and apparently they're doing a really phenomenal job bringing more women into those leadership roles. So it's really going to depend on what region you're in. And then with the ethnic and cultural diversity, it's the same thing. Like, you know, depending on where you're at and what the demographics are, it might not be a huge issue on the ethnic or cultural issue. But here in the United States, we're pretty much the melting pot of the world. We have different ethnicities, different cultures, different identities, and companies really need to start thinking about, okay, if we do bring awareness to these different groups, then how can we make the work environment, inclusive and comfortable for those different ethnicities and cultures? Because again, in the United States, manufacturing has been predominantly white. And a lot of people aren't comfortable with some of the things that are still going on today, unfortunately. And it can be an uncomfortable conversation, but I always tell people, if you can have those conversations and figure out a solution, it's just going to be better for all of us overall, because embracing diverse backgrounds and perspectives, it actually fosters innovation, it improves problem solving, and it enhances overall productivity. So it's really good to think about how you can make your work environments more inclusive. And then the third one is an interesting one. It's skills and experience diversity. So there seems to still be this argument about, what it means to be successful. And I remember when I was going through high school, success meant you had to have a 4-year degree plus more. My mom always tried to convince me to get a doctorate, and I just didn't like school. And we need to start understanding that everybody learns differently. Everybody remembers things at different paces. It's really going to depend on what your passion is, what you like doing, what your life experience is. And, you don't necessarily have to go to a 4-year degree college to be successful within engineering and manufacturing. So again, it's about, collaborating and having a combination of those educational levels and industry experience as well too. So we all have something to contribute to the pot of knowledge that is manufacturing. So how do we connect those generations with one another? So baby boomers have a lot of industry experience. They have a lot of that industry knowledge. It's still going to be very important. So how do we save that industry knowledge? How do we document it? How do we pass it along to the next generation? A lot of Gen Z, they're considered the digital natives. They're going to be able to pick up those technologies at quicker paces than the older generation. So how can we get them to work together and mentor one another? Because again, it's going to help foster innovation. It's going to help make us more productive, and it's going to give us a competitive edge if we can just combine everybody's experience and education and come up with better solutions than the rest of the world is coming up with.
Wow, you said so much that I found interesting there. It brings me back personally to a conversation that I had just today with one of our customers here at SolidWorks. His name's Sanket Patil. He works at Behlen Corporation, and he was talking about the concept of organizational memory. Such that how do I, for those of you at home, and I hadn't heard of it in years, this concept, but really what it speaks to, and you might very well know this, Meaghan, it speaks to this idea that at each company, namely within companies, within organizations, that there are a number of people, maybe teams, maybe subgroups at companies that have this knowledge of practices and ways of doing things, right? And that organizational memory is at risk of lapsing. Say if a team disbands, or if a particular person with all this organizational memory leaves, right, you can just kind of lose it. That's super risky. And I think what you're speaking to, it makes me think even broader than organizational memory, but maybe generational memory, right?
Right.
Which is crazy scary to think about in a way, but this idea that potentially, we have so many skillful members of the workforce that are maybe more advanced, maybe further along in their careers, and sort of bridging that generational gap, I think is perhaps maybe to your point, more important in a lot of ways than ever. Yeah, you said so many things there. One thing, going the other way, just on the topic of diversity and the importance of having difficult discussions. I read a book recently. It is not by any means a new book, but I think a lot of us have probably either heard of it or read it, called The Last Lecture. And it was by a Carnegie Mellon professor named Randy Pausch from the computer science department. And it's a series of really short lessons. And one of the lessons that he said was passed down to him from his parents was, if you sense that there is an elephant in the room, go ahead and name the elephant. It can be hard, it can be difficult, it can be super uncomfortable, but things almost always tend to get better when you do that. So I think like just being in a space where, and I think a lot of our community members lead the way in that way too, like just being in a space where you can have those conversations and acknowledge facts and try to make things better, I think is super important. So Meaghan, over the past, let's say 2 years or so, where are we seeing the biggest strides within diversity in manufacturing?
I think there's a couple things that I've been seeing. So there definitely is a big push, as I mentioned before, with getting more women involved in engineering and manufacturing. But there's also a lot of conversations surrounding like when is the right time to get younger generations involved and exposed to what's going on in engineering and manufacturing. So initially, we were pushing career pathways when they got into high school, maybe at sixth, seventh, eighth grade. But we generally don't like encourage kids to pick what the rest of their life is going to look like until they hit high school. And then that's when they start making connections to the workforce. And now they're saying, well, what if we start exposing them even younger and have them, follow through with a career pathway? So some schools are changing the way that the curriculum is. They're having like they're not necessarily called tracks, but this is what they called it in Milwaukee when I went to college there. You could pick a track. So if you want to be like a firefighter or a police officer or somebody in healthcare, that would be one track. And then engineering and manufacturing would be another track. And then they formulate your curriculum around the track that you choose so that you're taking things that actually lead you to success in those specific career pathways, and you're not wasting your time like if you're in the medical field on a political science class, because they're not connected. I mean, they are at some degree, but you get the point.
I do.
So I'm seeing that, and then there's a lot of organizations that are being created too that are focusing on different demographics. So like I've seen a lot of organizations that are focusing specifically on BIPOC individuals. There's some nonprofit organizations that are focusing on uniquely abled individuals and second chance citizens. And WIM is a great organization. It's the Women in Manufacturing. They have different programs. So they have an event coming up where it's Moms in Manufacturing, and it's a virtual event, and it just talks about, moms who are in manufacturing, and they have different keynote speakers. They also have a really good professional development program that you can sign up for. So it helps women with their leadership skills and figure out like where they want the trajectory of their career pathway to go. And then they have a bunch of virtual learning series that you can sign up as a member. And then specific individuals that I've recognized, one is Kara Branch. So she started out as a chemical engineer, and her 9-year-old daughter came up to her and asked her, or actually told her that she wanted to be a computer software engineer. And Kara was like, I didn't try to influence them in any way, because when I was working, I was most of the time the only female, the only Black female. And she's like, so I felt all kinds of adversity, and I didn't want my daughters to go through that. And she's like, I just was completely blown away that she came up and told me that's what she wanted to do. So that was a sign to me that she's watching what I'm doing, and she's being inspired by it so much that she wanted to pursue that pathway. So she created a non-for-profit organization called Black Girls Do Engineer. And within the first 3 years, I think she developed like 2 or 3 chapters, and she's in the Houston area. And then the Society for Manufacturing Engineers, they have a women division. They partnered up with Women in 3D Printing. So you're seeing a lot more collaborations between some of these organizations too, so that they can build bigger events and focus on some of these gaps that we're seeing. And that's a really good thing. Danielle Boyer, who she's a SolidWorks champion. She's phenomenal, and her nonprofit called the STEAM Connection, she's really working on getting, robotics in front of indigenous tribes and, providing them with free kits so that kids can learn about robotics in indigenous communities. One of my personal friends, Allie G, she's part of Automation Ladies, which is another podcast, but she also has her own business. She started this non-for-profit called I'm going to mess up the name, Allie. I'm so sorry. It's like Kids PLC Kits or Kits. It's something like that. But she's basically collecting all of these PLC components and sending off free kits to kids so that they can actually get hands-on experience with what she's actually working with in the field. And she's following all of the safety regulations and everything like that. And I just thought it was really cool that she's doing that for free. And then if you don't know Andrew Crow, I'm going to ask you to get out from underneath your rock because he's actually
he's all over the place.
He's all over the place. And he actually touches on all of these groups that I just mentioned. So he's not just advocating for more BIPOC individuals, but he is advocating for women in manufacturing. He's advocating for second stats and uniquely abled. And he's doing this with the new Manufacturing Renaissance tour that he's taking all over the United States. And the cool thing about it is it's not just his brand. Like, yes, he's the leader of it, but he is trying to get other people to be more proactive within their own community. So I highly suggest like everyone to follow some of those individuals that I suggested because they are the people putting the boots to the ground and pushing for some of these changes to happen. And it's really cool because companies are starting to see, well, yeah, I can't really do this on my own. And if I do need help, I can reach out to certain people and maybe have them come in and talk about their experiences. So those are a few of the things that I've seen that's been really making a difference.
Wow. So for everyone watching today, we will have all of the links to all of these organizations that Meaghan just mentioned in the description for the video, just so you'll be able to check out. Some of these I knew of, and some of these I did not. So I will be sure to, as we put the links in the description, visit these organizations myself. One story, just to relate, Meaghan, that comes to mind for me in terms of kids, right? Kids that find themselves potentially wanting to get into the trades or wanting to get into manufacturing or engineering or anything regarding STEM. That I can share is actually our daughter. Just the other day, it was kind of a learning moment for me, because what I find is that sometimes it doesn't it's not always so obvious what's going on, right? So one of the things that I found was that she brought up a toy to me, and she had seen some sort of video where toys were getting fixed. Where they put the toy in the chair and they were going in and like taking out like parts of the inner workings of the toy and just fixing things. And she said, I want to do that. And I was like, oh, cool. So yes, I could have, there have been times for sure I've been very tempted to say, here's a kid's coding app, like go use that. And like, this is very obvious. But sometimes it just comes up in like ways that you don't expect, right? And I find those things to be really, really neat. So yeah.
I always try to encourage parents with smaller kids to like really pay attention to them, because I was one of those parents where when I had my daughter is quite a bit older than my two sons, and I was a single mom working all the time, so I missed a lot of those small moments where I could have probably picked up on what she was passionate about or what she would have probably geared towards. But with my two sons, my youngest, Ronan especially, like it cracks me up because he likes to smash things, and everybody's like, oh, that's so destructive. But it's like, if you look at him while he's doing it, he's not just smashing it and laughing and then walking away. He's like looking at how it breaks and how it separates, and then he tries to put it back together. So he's curious as to why things are put together the way that they are. And the other funny thing is, once he figures it out, he's just like, I'm done with that. And then he just tosses it behind him and he goes and does something else. So I think we need to do a better job at like connecting with the younger generations and really figuring out what their core values are, and getting an understanding of that. And the other thing too is, I think the government has now caught on that we really need to start building manufacturing up again. So you are seeing a lot of initiatives towards funding and grants specific to STEM opportunities. And I was talking to a woman from First Robotics, and she was telling me how it's in Wisconsin. So I think depending on what state you're in, the grants are going to differ a little bit. But she was telling me how the students had to present in front of the senator of the state so that they could increase the grant that they have currently, so that they could use it to fund some of their robotic stuff. And she said it was really cool that these kids who are like 11 or 12 have the confidence to speak to our government leadership and, you know, convince them that we need to increase this because here's the value for all of that. So definitely don't look at it, oh, well, they're young, they're inexperienced, they don't care. Give them a chance, because if you like give them that hope, they can take that so far, and it's just really refreshing to see. So yeah, pay attention to kids.
It's great ending thought there. But Meaghan, and for everyone watching at home, of course, we will tag Meaghan here with Mavens of Manufacturing. An outstanding effort. I've learned of so many interesting people through your work, and giving women a platform in various manufacturing capacities. Some of whom I know, and I was happy to connect you with, and others I became aware of for the first time. But yeah, you're doing some great work, and it truly is a privilege to be able to chat with you. So thank you so much, Meaghan.
So much. Yeah, thank you.
All right, thank you once again to Meaghan of Mavens of Manufacturing. This final topic really, I think, ties it all together in my mind. Throughout this whole episode, we have seen and heard about vast amounts of manufacturing technology. We have heard from mentors. We've heard from leaders in challenging the status quo in so many senses of that phrase, really within and around the world of manufacturing. And our final guest today is a SOLIDWORKS champion. He works as a manufacturing engineer. He has his own company as well, Black Hand Side Design, and he's a mentor through this company as well. So if you think about it, in many ways, Eric Timmons, our next guest, is a testament to so many things that we have talked today when it comes to challenging the status quo. And he's here to speak to us on a topic that I think many of us find so important, which is design for manufacturing, but also paying it forward. So here he is. Eric, how are you? Welcome to the show today.
Hi, I'm doing well. How you doing?
Good, man. So Eric, you've been a mechanical designer for many years now. You work for Autoply, a company that makes automotive installation kits, and you also own your own company, right? Black Hand Side Design. So tell me about this topic. Right? This topic is all designed for manufacturing, and I wanted to ask you, what are some personal stories that you can maybe share from your career, specifically on, how knowing a part's manufacturing method either changed or influenced how you 3D modeled the part or even made a print for it?
Say with Autoply, because we work with panel vans, so panel vans look simplistic enough. But the thing to understand with the van is that the curvature on the inside of the vans, you have the A pillar, the B pillar, C pillars, you have little obstacles there. So they can create shortages as it relates to the lengths whenever you're cutting. Because basically what we're doing, we're using a special manufacturing insulation that has a special type of glue on the back of it so that it can withstand the heat, the wet, and all of the cold, and still adhere to the inside of the panel van. And then also it has to go along the curvature of the inside of the van. Well, it's almost like sheet metal design, because when I'm designing these panels, I have to create a little bit of a curvature there so that when they actually lay out in the van, they'll lay out accurately and they'll cover all of the spaces that we want to cover. It's kind of like say you wrap a gift. If you cut it too short, then you get to the end like, okay, well, I can't add on after I cut. Yeah.
That's super interesting. I think all of us can probably agree. In the chat here, watching the episode or wherever, really just in this industry, that it is so, you can become so interested if you're a curious person when you hear about the different stories, the different design manufacturing methods that people have to consider within their own work. Like you said, you might look at a device and anything in the room that you're in, and you might think, oh, I can probably figure, what has to go into making this or that. But then when you actually talk to someone like you, it's like, no, not really, not always. Like there's so much that you learn that maybe you're not going to learn in like a SolidWorks basics or beginners course about making something real, right? Like it's not always going to be something that you pick up in a CAD course, but through the course of making something, it does, I'm sure, inform how you design your CAD work, right?
It does, because people get so excited about today the model year changes, and the new models are coming out at the end of the year. Well, it can also be a headache, because you're like, oh, new models coming out. What did they change? Is my last year's patterns gonna work? And typically they don't. So you back to the drawing board to create a new thing for that supplier, and why it's exciting is also you're like, why can't it just stay the same?
Yep. It's there are so many external sort of real life ramifications that sort of affect, right? Like how you start, go back to the drawing board, go back to the model, and you kind of reset things. So yeah, that's I think for anyone starting out their career, because it's funny, and it is inspiring in a way that you or I, like, we'll go on LinkedIn or we'll go on Facebook or Instagram, we'll see these like really beautiful CAD models. So many students out there are so talented, but then there's this whole other world that you have to enter into if you're ever going to make something, where it's like, oh wow, like
Yes.
there's so many other considerations other than making like my parts and assembly perfect.
Yes. I remember my first part. I did a bracket, and I think I was doing it for a military customer. And I just did the bracket. It was kind of U-shaped, just did it. And after I got finished with it, it was so perfect. And then my manager walks up beside me. He says, "Now make that a flat pattern." And I was like, "What's a flat pattern?" Because I did it in regular modeling. I didn't do it in the sheet metal function. So of course, it wouldn't lay flat. And so I'm like,
Yeah.
oh. So I did not make it with manufacturing in mind at all. I just made it the way I learned in school. Just went into SolidWorks and made an extrusion and bop 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 bop. And I was proud, but it was not in sheet metal, so it wouldn't lay flat. So I did not design it for manufacturing. So yeah.
That's the thing. Yep. And it's, this episode, it's about, very broadly thematically, it's about challenging the manufacturing status quo. And I'm inspired by someone like you because, like I've kind of alluded to already, you have years of experience as a mechanical designer. You work as a designer at Autoply. You have your own business, Black Hand Side Design, and
Right.
Another aspect of Black Hand Side Design, as I understand, is that you also do mentorship there, right?
Correct.
What do you think, from your perspective, what do you think younger generations really need to focus on these days when it comes to design for manufacturing?
The first thing for me, typically the schools that I go to are the schools that we call underfunded, which is bananas to me that we could even have such a term in what would be considered the richest nation on earth, that we could have something that's called underfunded schools. So the main thing for me is to get them introduced to it. So like for me, I take my hand scanner, I take my laptop with me, and I introduce them. I have a Sense hand scanner. I introduce them, say, hey, scan your butt. And they're like, what is that about? And most of them don't know that there are like apps on your phone that you can use to scan something, or they've never been introduced to it. I consider myself an accidental engineer in that I kind of came into engineering by accident. My first product was called the Perfect Tree, and I designed that back in like 1999, I want to say. And it kind of is a Christmas tree in the shape of a cross. And I took some 2x6s and put them together and took some garland, wrap them around, kind of made it the shape of a Christian cross kind of thing. That was my rudimentary way of doing it. Now, me and you both know nowadays, we're doing that thing in exploded views. We're specking out,
Got a
we're
fancy
specking out the type of
rendering. Don't even
PVC
buy
on
garlic.
bro. I got the poles already designed. I'm telling them how long I want the garland to be on either side of it. So it's totally
Yeah,
different now how we do it as opposed to then. So for
sure.
me, introducing them to it is the most important thing. That they actually know that there's a realm for all of our information age out there. There's so many kids that don't know anything about practical engineering. They think engineers, all we do is send people to the moon, or something like that. They don't know about the other intricacies of how we affect their everyday lives.
Those are really, really, really great points. Well, Eric, I want to thank you so much for jumping on. I also want to thank you for joining the SolidWorks Champions program.
Yes,
which
I
is
love
how we met. Yeah, man. And for those of you watching this episode today, check out Black Hand Side Design. We'll put the links in the description and the chat.
Thank you so much.
But once again, man, thank you so much for jumping on.
Thank you for having me. You have a good day.
All right, so thank you so much to our guests, Chris, Jeremy, Meaghan, and Eric for all of your hard work and dedication. Thank you to the Herculean efforts of my friends here at Dassault Systèmes, namely Ian Adair, Matthew Clegg, and Mike Buckley. Thank you all for everything you have done to make this episode possible, and just the many hours of thoughtful work that I think is necessary to allow this aspect of our community to not only exist, but to thrive. And of course, thank you to our viewers, our audience, our community. Be sure to subscribe, and we will see you next time. Take care.